let's start looking at this. What I want to do is start talking about how you graph these. And I'm going to bring this back to something we've already done. I'm going to bring this back into working with a quadratic. Now, working with a quadratic is still a polynomial. Do you agree? Yeah. It's just a squared term. Now, we've done this in the past where we've worked with them in this form. Remember what this form is called?
It's math.
It's the one. Which one? You're narrowing it down.
What's the name?
No. Intercept, right? Come on.
Oh, right?
Yeah, it's intercept form.
Yay!
Now, from this value here, these are your two terms of the polynomial. It's not FOILed out. If these are your two terms, what are then your zeros?
2 and 4.
Okay, so when you went to go graph these before, you plot them at 2 and -4, right?
Right.
Thanks. Now, you also should remember what it means to look at the tails of the polynomial. This is a second degree polynomial. Is the first term going to be a positive or negative? Positive. So which way do the tails go? Up. So we know that tails are going to be going up. Now, we also talked about this, since this is a second degree polynomial. Ooh, degree. You will have one direction change. Since it's a second degree polynomial, you will have a maximum of one direction change. Correct. Now, we know that our tails are pointing up, so it's going to do something like this. Right?
Yeah.
Now, according to this graph, there's a few things we'll be able to figure out. One of the things I want you guys to start getting the habit of in this section is to always plot your y-intercept. I want to figure out where our y-intercept is. Now, when you have your y-intercept, it might be going through here somewhere. What will always be your x value at your y-intercept? 0. Now, if I'm looking at our original function, f of x is synonymous with what? Y equals. So if I know that my x value is 0, could I figure out what my y value is?
Yeah.
So all we're doing is just substitute it in. 0 minus 2 times 0 plus 4.
Oh, it's -8.
-8.
That's nice.
So your y-intercept then is at 0, -8. Are we okay with that? Now, the other thing that we've done in the past with these is that you've been able to figure out what a minimum or maximum would be. With this being a quadratic and it's pointing upward, we all know from previous chapter, this is called the vertex, correct? Is that vertex a maximum or a minimum? Why is it a minimum?
It's not going to go any further.
The bottom. It's not going to go any further. So this is, we call that the minimum. Now, the nice thing is that you were able to find those minimums before by finding the axis of symmetry, substituting back and forth, and going that route. But remember, your calculator does it too. So grab your calculator. I told you yesterday to bring your calculator. So put it, the function in exactly what it was. It was what? X minus 2. Put it in parentheses just like that. And then x plus 4. And just go to your graph. Okay. So when it looks like that, what I want you to do then is remember how to calculate the minimum. What do you have to press?
I did the same
Second trace. Yeah. What's
I
that?
did the same thing and then I came out.
No, you did it wrong.
Wait, but did you say that?
You used a negative symbol.
And then,
Duh.
and then it shows you when you press second trace, it shows you your y-intercept.
Yes, sir.
Not my finest moment.
Yes.
Yeah.
But over there, its lowest point isn't on the.
Oh, no, I didn't say it was the minimum. I said it was the y-intercept.
Yeah.
Yeah. When I go through this, I want to find the minimum. So I hit second trace for the calculate, and I select number 3. And this is where your calculator is going to ask you those questions about the left and the right boundaries. Remember how we moved the calculator around to figure that out? So you just move to the left of where it looks like, move it to the right of where it looks like, and then it says guess, and you say, whatever, and hit enter. And it's rounding it out to be -1 point something, lots of zeros, and 9. Negative, excuse me. So what's my minimum? My minimum is at -1 and -9.
Oh, yeah. I got you.
Because that's what the calculator told me. A little bit of rounding. Okay. Now, what changes now from what we've done in the past as far as a quadratic into some of the cubic or the quartic styles, the 3rd and 4th degree, really is nothing, except that you get different changes of direction. So we'll show you. Let's plot a 3rd degree polynomial. I have a 3rd degree polynomial that says f of x equals 1/4 times the quantity, x plus 2, times quantity x minus 1 quantity squared. I wrote a little hint down there that right off the top that it's a 3rd degree polynomial. And the reason that I know it's a 3rd degree polynomial is why? 3 x's.
You're going to have a -2, a 1, and a 1.
Right. You'll be 3 zeros. There's 3 x's, so those become 3 zeros. Yes, sir.
Except 1/4.
1/4 is just a constant. Yeah, 1/4. That 1/4 is just a constant. That's just telling you what direction it's going. So it'll be it's positive. It's positive. So it's a positive 3rd degree polynomial. What are the tails doing? Yeah, it's like a positive slope. Okay, it's like a positive slope. So we know that it being a 3rd degree polynomial, the trick is that you will always have up to 1 less your degree changes to directions. You could have up to 1 less the degree of change in direction. So this function could have up to 2 changes in direction. Sometimes they will have 2, sometimes they'll have 1. It just depends upon the number. Remember, some of our polynomials that we've worked with have imaginary solutions. When you graph imaginary and real solutions together, you might not see changes in direction. You might not see them all. That's why it says that it might have up to 2 changes in directions. Just like when we first started working with our polynomials back in 6.4 and 6.5, or 6.5 and 6.6, where you'd have a 4th degree polynomial, and we would say that it could have up to 4 zeros, but we'd only find 2 real. Then later on, we found out that the other 2 were imaginary, so you had a total of 4. It's kind of along the same lines here. So in this case here, what I want to do is plot my zeros. Our zeros are at -2 and +1. Well, what's happening at the +1, 0? Yeah?
It's going to go like by it, but it's going to change directions right after 0.
Very good. Remember what happens when you had a parabola that was x minus 1 when you graphed that originally? It just hits the 1 in one spot and does that. It's the same idea here mixed in with the other polynomial. It's just looping at that singular 0. No, it just changes some of the outer edges. It's no big deal. That 1/4 is just going to show you if it's going to wind up being a positive or a negative function, really. Okay. So with knowing what our tails look like, we know our tails are going to be going up and right, similar to what a slope is. We begin doing this, right? Still got to find the y-intercept? Yes, that too. The y-intercept. If I want to find the y, I guess I can't chew gum and talk. If I want to find the y-intercept, what's my value for x? 0. So my y-intercept is going to be at, it's going to equal, let's see, 1/4 times 0 plus 2 and 0 minus 1 quantity squared. So what's 0 minus 1? What's negative 1 squared? What's 1 times 2? What's 2 times 1/4? 1/2.
Really?
What's a fourth of 2?
Sorry. Hi.
So your y-intercept is at 0, comma 1/2. We okay with that? Now, if you notice, you have 2 changes of directions, which means you have both a, what's going to be called a local maximum, and this would be a local minimum. Yes, in this case, you know that your localized minimum is at 1, 0, because it changed direction at that spot. You knew that over here. Yeah?
Why are they called local?
Because it's in this vicinity, there's a maximum. Because if you go on to your infinite tails, there's no maximum at infinity. But you know within this range in here, there's a maximum value. Within the range here and here, there's a minimum value. So if that's what you're looking at, you're looking at a specific interval of time to figure out what the maximum might be. Now, this local maximum and minimum, you're using the same buttons on your calculator for, like you would normally, a maximum or a minimum. I might as well let me delete. So let's put this function in and take a look at it.
Wait.
For, what's that question you heard you say, wait, oh, what's wrong?
Oh, wait, how do you do the fractions?
Just put 0.25. Or hit alpha y equals. Okay? Whenever I have a fraction that's very easy to use, like 1/2, 1/4, 3/4, something like that, I'll just use decimal as I'm putting in the calculator. It's just a little quicker to type. They are for chumps, but for ease of use in the calculator.
Oh, that's cool. That's fine. You got,
You got 2 X's and 2 X's.
yeah.
Oh, you see that?
No, that's actually it's a 5th degree polynomial at that point. Because I have x times x quantity squared, so it's x to the 4th times another x.
Wait, no, wait, we already have it. Wait, now what do you want to do?
Now, what I want to do here is everybody agree that we know that the localized minimum value is at 1 and 0. When you look at it, we know because it's changed direction, so it's at 1, 0. So that's not a big deal. What I want to do is find the maximum. I'm going to find the maximum in that range in here. So we just hit second, calculate, and now just pick maximum. And you're just going to move your cursor around to create that interval that you're looking for.
Yes. It says -1 and, oh, that's cool.
And your localized maximum is at -1 and 1.
Oh, I got here.
It's not always, you might have had your boundaries put on the wrong sides, Christian. Sometimes it happens. If you get an error message, you might have selected the wrong boundaries.
Might not have like that, but now all the way right on When it says guess, you can just hit enter.
Yeah, you can just hit enter. What the guess value does is that if you, let me show you. In this case here, if I hit my second calculate, I want to go to a maximum again, which is 4. I select my left boundary, and I'm over there. I go to the right boundary. So I'm over here. Now the guess, it wants you to just move your cursor a little bit closer to the middle, and then it's just going to approximate a little bit better. That's all. It is. It's silly.
I don't do it, I just.
I don't know. I have no idea. There must be some reason.
Maybe there's like another way to use it.
There might be. So what I'm going to ask that you guys do when you're doing your homework with these types of problems is to label out zeros, localized maximum, localized minimums if needed. Sometimes it'll just be a maximum or a minimum, and what your y-intercept is. Not too much, right? Sir? Yeah.
Why come out with 1.016?
It's just rounding it out to 1. But if you just trust the fact that you know there's a change of direction at that spot, you know that's not good. Yes, sir?
I got -0.9999.
It's -1.
Okay.
You have to trust that you're close there. Don't get me wrong, there will be some crummy maximums and minimums, localized max and mins. You're just gonna round them out best you can. That's all it is, okay? They're not always as clean-ish as this. So, do this one. So, a lot of you guys figured out that you have zeros at -4, -3, and positive 3.
Plus or minus.
Yeah, plus or minus 3.
Nice.
Now, with my leading term here being -2, that means my tails are nearing slope being negative. So it's got to go down.
No, it's way higher than that.
But remember, I'm just approximating. Because now, what I'm going to do is find my y-intercept. My y-intercept, when I substitute in, I get -2 times 0 minus 9 times 0 plus 4. So that's 0 squared. So I have -2 times -9 times positive 4 gives me a positive 0, 72.
That's a big number.
Okay? That gets me my y-intercept. My localized maximums and minimums, then, all I have to do is just press buttons to my calculator to find them. I don't know exactly where they are, but you guys can do that, right?
Wait, okay, so.
That's really scary. It's Tom Ford.
Yeah, you're getting real nasty looking numbers. So let's do this a little bit differently then. Oops. Let's write the function given the zeros, or given ordered pairs. So let's go the other direction. Let's go the other direction. Let's take a set of ordered pairs, some of which being zeros, and we're going to write out the function. I didn't write down. You guys can press buttons for localized max and mins. I don't know.
I forgot how you did it.
What?
We did it like so quickly because we were like focusing on the problem because we were still like finishing it, and you were already done.
So now, what I want to do is I'm going to write out a cubic function. Cubic function means what's the degree going to be?
What the? 4. Just kidding. Yeah, 5. No.
3.
Just kidding.
27.
Oh,
I was thinking cubic and cinco.
My bad.
So what's going to happen here is that every one of these is going to follow the same pattern.
Wait, what
There's-
are these?
There's ordered pairs, some of which might be zeros, and I'm going to show you what's happening. You're going to have a cubic function, which means you're going to have 3 terms. Do we agree? You're given, if you think about what's happening on a graph, if you look at these ordered pairs, you have a 0, and a 0. So if my 0 is at -3, what's my term?
Plus 3.
Okay, so my one term is at x plus 3. What's my other terms?
X plus 15. X plus what? 18.
Is 15 a 0?
No, wait, they're going to sorry, you guys sorry, Mr. Rex. They're going to give us this graph to look at.
Not always. If you don't get a graph, couldn't you just plot it real quick?
Yeah.
Okay. So right now you've got your 3 terms. You don't know what your A value is, that constant that shows you how fast it's rising or skinny or whatever of the oscillations there. So what I want to do is, I want you to remember again, what's another name for f of x? Y equals. So could I do this where I know that y is going to equal a x plus 3, x minus 2, x minus 5. And don't I have another set of ordered pairs, which means
And that's the y.
there's your x and your y. What I'm going to do is use that 4th set of ordered pairs to substitute in. -15 is going to equal a 0 plus 3, 0 minus 2, 0 minus 5.
Oh, and then you plug in, or you
Oh, yeah,
substitute.
what's A?
A is that constant out front. You know how the one a second ago we had that 1/4 times all that junk? That A value is, yeah, that A value is going to tell you, basically it's how fast the graph is moving. What are your peaks and valleys at?
Okay, so basically, okay, if you have like an f of x and then like the like function, okay, if it doesn't have something in front of it, does that mean it's just 1? And then it's like
Yes.
positive?
Yep. So what happens here when you solve all that through, you get 3, -2, -5. You multiply those together, you get what? You get positive 30, correct?
Yes. Yeah.
So -15 is 30a. So what's your value of a?
Negative
1/2. So my final answer for this function then would be f of x would equal -1/2 x plus 3, x minus 2, x minus 5. And if you look at your graph, notice how that leading term is negative. Your tails are in the same, going the same direction as the negative slope would. You're just matching it up with that. Yes, sir.
How do you know that?
Good question.
What's the maximum?
You don't have to find those, but you can put that function in your calculator and calculate that if you wanted to. Your calculator will do that work. So try this one real quick. This is a 3rd degree.
I already did.
So if you start plotting it,
Oh, and then you, I get it. I get it.
you have that. Right?
Yeah.
Okay. So that means I have my f of x is going to equal a x plus 2, x plus 1. And what do I put on the last one? X. You can put x plus 0 if you want. You can say-
No, she tried putting the 1.
Oh yeah, because it's not a 0.
Oh, it's the same thing.
Okay. So now to figure out what your a value is, what's your y value?
-3. Or
When x is
1.
what's 1 plus 2?
3. 1, 3. X plus 1. What?
This was not a trick question. What's 1 plus 2?
3.
3.
What's 1 plus 1?
2. He's just going through the.
Oh, all right.
What's 3 times 2?
6.
Times 1.
6.
Yay, Ellie.
So your a value is -1/2. So you have f of x now, when you go to plot this, with it being a negative, which way is it going?
Down. Up.
Which way is it?
Oh, up because it's a 3rd degree.
No, they all go up and down.
Up and down.
That's it. I mean, I did that.
I almost had it. I got
And then you can use your calculator to find your localized maximum.
We're going to have to do all of it.
Well, you're doing the graphing of it later, but this is a good, easy way to check to see if you're right.
I'm starting to grind.
Okay. So what I want you to do tonight is a couple of these.
But I'm like 3 hours. I just have to take it. I should have taken yesterday. I've been taking it.
That's a lot of things to know. Stop your whining.
8 problems. Get over it. Wow. Sorry, 9. Okay. When I have those things on about graphing, make sure you plot your zeros, your y-intercept, localized maximums or minimums. So if it winds up being a quadratic, you're only going to have one of them. If it's a localized maximum or minimum, it means you have more than one change of direction. The last section, it's basically what we just did. You'll have to figure out to write the function given the sets of ordered pairs. I believe they are all third degree. I don't know if there's a fourth one in there or not. I actually don't remember. But it's pretty straightforward. If it's a fourth or fifth degree, the process doesn't change. Okay?
What did you guys? We worked at it yesterday.
Yeah.